Hey there, geometry. This is lecture 6.3 about how to prove a quadrilateral is a parallelogram. So in section 6.3, they give you a variety of theorems on how to do this. So on one hand, in the previous lesson, we talked about if it's a parallelogram, that it has these properties. Many of these are just the converse of that. So what you're trying to do in this situation is, now you know you have a quadrilateral, is it a parallelogram? So the first one states if the opposite sides of a quadrilateral are parallel and congruent, then it's a parallelogram. The next one says, hey, if the opposite sides are congruent, if both sets of opposite sides are congruent, then it's a parallelogram. The last one here says, if a quadrilateral's both sets of opposite angles are congruent, then it's a parallelogram. And then, if one angle in a quadrilateral is supplementary to two adjacent angles. So this angle here is supplementary to this one and to this one. Well, guess what? It's got to be a parallelogram. And then last but not least, if the diagonals of a quadrilateral bisect each other, they cut each other each in half, that's got to be a parallelogram. So these 5 rules combined with the definition of a parallelogram. What is a parallelogram? It's a quadrilateral where opposite sides are parallel. So you've got 6 ways to tell if a quadrilateral fits the conditions of a parallelogram. And the advantage of that is, well, once you know it's a parallelogram, then all these other properties come to be. And so you're going to get questions thrown at you like this. It says, show that JKLM is a parallelogram if A is 3 and B is 9. Well, when you plug in 3 for A and B for 9, you can find out if those opposite sides are congruent. And if they are congruent, then you know it's a parallelogram. Let's go ahead and do it at the board. I'll try to talk loud so you can hear me. So 3 goes in here. 3 times 10 is 30, plus 4 is 34. In here as well, 45 minus 11 is 34. So boom, I know those 2 sides are congruent. Now, maybe it's a trick. Let's try this one. I'm going to plug in 9 for B. 9 times 8 is 72. 72 minus 21 is 151. And then I plug in 9 up here. 45 plus 6 is 51. Aha! In fact, I do have 2 sets of sides that are congruent, so therefore it's a parallelogram. So again, you've got these 6 ways to tell if something's a parallelogram. Here, well, wait a minute. This angle is supplementary with this one and with this one. It's definitely quadrilateral, therefore this is a parallelogram. This figure here, opposite sides aren't congruent. No, opposite sides aren't congruent. This one, does that have to be a parallelogram? No. So, and again, to say something is a parallelogram by definition, then you must show that both pairs of opposite sides are parallel, like in this problem. So in this problem here, let me just get myself out of, yeah, I can go over here. Aha! In this problem, it says, show that this quadrilateral is a parallelogram by using the definition, which means you have to show that the opposite sides are parallel. So first thing I want to do is plot the points. So J is -1, -6, 1, 2, 3, 4, 5, 6. K, -4, -1. 1, 2, 3, 4. L is 4, 5. 1, 2, 3, 4. And then up 5. 1, 2, 3, 4, 5. And M is 7, 0. And I don't know. 1, 2, 3, 4, 5, 6, 7. So I don't know whether this is a parallelogram or not. Let me just throw some little connector lines in here. You guys like little connector lines, I'm pretty sure. And I'll make them I'll make them yellow. You guys like yellow. Hey, there we go. And again, it might look like a parallelogram. It might not look like a parallelogram. But I don't really know until I figure out the slopes of those sides. And so that's actually what I'm going to do right now. Easy way to do it. Rise over run. I'm going to go 1, 2, 3, 4, 5, 6. Up 6 over 1, 2, 3, 4, 5, 6, 7, 8. So the slope of this one is 6 over 8, which is really 3 over 4. Let's check this one. I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. There we go. There's my mistake. So I do go up 8 and 6. So the slope of this one is 6 over 8. That's bad counting. You guys figured it out, which is 3 over 4. So these sides here, I know, are parallel. Sweet. Now I just need to check the other ones. So this one I'm going to go down 1, 2, 3, 4, 5. Down 5 over 1, 2, 3. This one here 1, 2, 3, 4, 5 over 1, 2, 3. So this is also negative 5 over 3. Opposite sides have the same slope. Same slope means parallel. Both sets of opposite sides are parallel. Therefore, it's a parallelogram. So again, you should have this very easily together, and I guess just easy ways to tell. These are the 6 easy ways to tell if something is a parallelogram. Last question, pretty short lecture. It says the legs of the keyboard tray are connected by a bolt at their midpoints. Well, what does midpoint mean again? Midpoint means to cut something in half into 2 congruent segments, like that. Oh, you guys like the purple, I know. That's cool. Akalina, you like that purple? Okay. Now, why is PQRS a parallelogram? Let me just put this in PQ, Q to R, R to S, up here like that. And then might as well put the, I'll just connect that one too. Why is that always a parallelogram? And you could easily say, well, it's a quadrilateral that the diagonals bisect each other. And that's enough to say, well, then, yeah, then I know that this is a parallelogram and everything else is all good in the hood. Hope that helps. Please try those problems that I've assigned from section 6.3, and afterwards, move on to the next thing.